Ashton. They're not friends yet, but we are going in April. I'm hoping that gives it enough time to like fizzle out, you know. Let the drama subside. No, you're fine. All right. What did you say? Here, I'll take it. Yeah. All right. Okay, our plan for today is to do fundamental theorem of calculus. Okay, see how I put fun? See on the notes? It says fundamental. Oh, it's no, I just said, see how I put fun in all caps? Oh. On the paper. Where? Okay. All right. So to make sure that you have time to work on your homework in class for a little chunk, talk about your spring break, whatever. Let's just get started. Fundamental theorem is based on this guy right here. A to B, f of x dx equals. Okay, can you tell me what the other half of that should say? So if I'm integrating little f from A to B, what's the antiderivative of little f called? Big F, and then remember, you're going to plug in B, plug in A, and then subtract. Do we remember this rule? Okay. So the fundamental theorem of calculus is this. The second fundamental theorem of calculus is when you take the derivative, so this is FTC. Okay, and then the second fundamental theorem of calculus says if I take the derivative of an integral from a to x on little f of t dt. Okay, so we're taking the derivative of an antiderivative. First, we're going to pretend the derivative's not even there. So just put your thumb over it, pretend it's not there, and we're going to use this rule right here. What happens to my little f? It turns into big F's, and then I do the top plugged in minus the bottom plugged in. So what would that say here? Capital F of x minus capital F of a. And then remember, in the front, we're taking the derivative of that. Okay, then from there, we're taking the derivative of the two big F's subtracted. So I'm going to distribute that derivative into both of these. So we're going to take the derivative of capital F of x minus the derivative of capital F of a. Okay, we're almost done. What is, now remember the relationship, little f, when I take the antiderivative, goes to big F. So now think in reverse. If I have a big F, and now I want to take the derivative of it, what would it go back to? Regular F. So this is going to go back to regular F of x. And then for your second one, A is a constant. So if I take the derivative of a constant, do you remember what we always get? What's the derivative of like 5? 0. Okay, so no matter what this constant is, okay, I want you to put here, this is a constant. Okay, then the derivative of that constant would go to 0, which means it's really just f of x. So now we're going to skip all the middle steps and write the second fundamental theorem of calculus. If you take the derivative of the integral from a to x, f of t dt, it equals f of x. Okay, that's what the second fundamental theorem of calculus says. Now, let's just talk through why that happens. This is a derivative. This is an antiderivative. what happens when you take the derivative on the antiderivative? Basically, these just cancel each other out. That's why your little f ends up still being a little f. It's because the antiderivative makes it a big F, but then the derivative knocks it back down to a little f. Okay? So all that you're going to do is cross out the derivative and the antiderivative and then swap out the letter. Okay, so this is very easy. So look at the first one. I want the derivative of an integral. Those cross out. And then I'm going to letter swap that instead of a t squared plus 1, now it's an x squared plus 1. Because the derivative and the antiderivative would basically just undo each other. Okay, take a look at number 2. I want the derivative of the antiderivative of negative 4 over t plus 1. Well, then if I take the antiderivative and then the derivative, I'd be back at negative 4 over x plus 1 now. Okay, but the only thing that's going to happen is a letter swap. Your actual equation doesn't change because you do one and then do the other and be back to the same thing. Okay, one more left like that. What is wrong with number 3? Okay, the x is on the bottom. The other two, it was on the top. You cannot use second fundamental theorem with the x on the bottom, but if I reverse this order, okay, there is a rule that says I'm allowed to do that as long as I apply a negative to the function. Okay. So if your integral is backwards, you should remember from, January basically, okay, that when you reverse the order of integration, you just have to change the sign. So my y squared sine y is now a negative. Now from there, I can use my second fundamental theorem. So go ahead and cross these out and do your letter swap. So now this is a negative x squared and a sine x. Easy? Okay. So let's work out, there are 2 types of questions that you're going to see on the AP test. Okay, let's start with number 4. Okay, if you have an equation like the one shown right here, and you're asked to find f of 2. Okay, this instruction means that you're going to plug in 2 for x in the f of x equation. Okay, so go ahead and write that down. We're not going to write it down every time, but you should know that if they ask you to find f of 2, that means take the 2, put it where the x is. Now, looking at your f of x equation, where is the x in this equation? It's the top of the integral. So I would do the integral from 2 to then I'm going to plug in the 2 they're giving me into this spot right here, which means it would be a 2. And then sine pi over 6 t dt. Now, in order for me to work out this integral, usually I take the antiderivative, plug in the endpoints, and subtract. Why do I not have to do that here? It's the same number, then what's the integral automatically going to be? Here. Okay, so there's a rule that says if these numbers match, you're not going to get any area because you're not actually integrating across anything. Okay, go down to part B. Now I want f prime of x. So notice this is f. Now I want f prime. That means I need to take the what? Derivative. And if I take the derivative of an antiderivative, what happens when I ddx in front of this? The equation stays the same, but I switch it to a what? Instead of a t, now it'll be a what? X. So it'll be sine pi over 6 x. So the derivative crosses out the antiderivative and just swaps out your letter. Okay, then from there, I'm asked to find f prime of 2. What does this mean that I should do? It means I should plug in 2 for x in what equation? Instead of f, now I'm going to plug in 2 f prime. So this means plug in the 2 for x in the f prime of x equation. Okay, which you just found. Okay, so my f prime of x equation is this. So where I see that x, I'm going to plug in a 2 to that spot. Notice it's not still in an integral because the integral's gone. Now I'm putting the 2 right there. So it'd be the sine of pi over 6 times 2. What is pi over 6 times 2 the same as? Just reduce this part. Okay, 2 pi over 6, which is the same as pi over 30. And then from there, I know it's been a while, but either unit circle or hand trig. I'm going to do hand trig. It's 0, pi 6, pi fourths, pi thirds. Then I fold it down. And where are my sign fingers going to be? The tops or the bottoms? Sin is down, remember? So it's going to be root 3 over 2. Okay, but notice that I want to reduce that pi over 6 times 2. That brings me to a pi thirds, and then I do my trig from there. All right, now I'm asked to take one more derivative. Okay, this is a little bit old, but we're going to need chain rule. So the derivative of f prime goes to f double prime. What is the derivative of sine? Cosine. Then remember, your core stays the same, but then you have to multiply by u prime. You can either put it in the front or the back. So if let's say this was a cosine of, let's say it's a 5x. What would the derivative of 5x be for me to times in the front? A 5. What if it was a 10x? I'd put a what in the front? 10. So if it's a pi 6x, what am I going to put here? Pi over 6. Okay, and it's the chain rule that says that you take the derivative of sine, it goes to cosine, keep the core the same, and then multiply that derivative. You can put it either in the front or the back. All right, so now let's find f double prime at 0. Okay, read me this sentence, but apply it to here. What am I going to plug in? 0 for x in what equation? Not f prime, but f double prime. So we're going to do pi over 6 times the cosine of pi over 6 times 0. What's pi over 6 times 0? What's the cosine of 0? It is 1. And then I'm going to have pi over 6 times 1, which is just pi over 6. Okay. So if you don't remember, cosine of 0 would be your pinky, and then you're counting your fingers up for cosine, which is root 4 over 2, which is 2 over 2, which is 1. Okay. All right. So if you are taking the AP test, you're most likely to see questions like this in the multiple choice. Okay, but for free response, my goal is that we only have to work through like 3 of these. Okay, there are a ton of examples, but hopefully we don't have to do them all. So skip the first one and go to the second one for me, please. Okay. So this can go by a lot quicker if we all really try to lock in at the beginning, because a lot of this stuff you know how to do. We're just kind of changing the way that you look at it. So this is a graph of what function? F. What are they asking you questions about? G. So we need to find on your paper what the relationship is between F, which I have a graph of, and G, which they're asking me about. So read right here. What does it say? G of X equals what? Okay, the integral from 2 to X of F of T dt. Okay, write that down. Okay, they gave me that. Now, I noticed that in part A and part B, they're asking me not only to find G, but to find G prime and G double prime. So let's do it. We were given this. I'm gonna put given here. Okay, but now we're gonna find G prime. Now, if G has an antiderivative in it, and I want to take the derivative of that antiderivative, what happens to the integral? Based on what you just did on the front page. Goes away. And I'm just going to keep what? F, but there's going to be a letter change. So instead of F of t, what is it going to be now? F of x. Because remember, when you take the derivative on the antiderivative, it crosses it out. You just keep the x, swap the letter. Okay, G double prime, I'm going to take the derivative again. What will the derivative of F be called? Very good. Now remember, this is a graph of F. So if I'm asked to do an integral on the graph of F, you will be finding area. Okay, so write that down up there to the side, that if I need to integrate F, I'm going to calculate area. What if I want F and I'm looking at the graph of F? What feature will I be looking at? Position, or I'm going to call it Y value, correct? Okay, so this is going to be the Y value. And then remember, this is the graph of F. So what feature would F prime be? The slope. Very good. So if they ask me about G, they're asking me to find an area. If they ask me about G prime, I'm finding the Y value on the graph that I was given. If I need a G double prime, that's the slope. So let's work through part A. Part A says to find G of 6. So G of 6 equals, and then I know from the front page, okay, that if they want me to find G of 6, I'm going to plug 6 into the equation for G, which is right here. Where is my 6 going to go? Where the X is, which is on the top. Very good. And then in my mind, I know that this means I'm going to calculate an area. So on your graph, will you shade the space from 2 to 6 between the graph and the x-axis? So 2 to 6 would be here to here. And then I'm only shading between the graph and the x-axis. What shape is that? Triangle. And remember, area of a triangle is going to be 1/2 base times height. What is the base? How many units? From 2 to 6 would be 4. And then how tall is it? So 4 times 4 is 16. Cut it in half is 8. So my area would be 8. Okay, next thing I'm asked to find after G of 6 is G prime of 6. But look at our work up here. Okay, if I want G prime, what am I really going to find? Regular F of 6, which is the Y value. And then I'm going to look at my graph and find my Y value at 6. What is it? 0. Next one I want is G double prime at 6. And then I would look up here at my work and I would say, but wait, if I want G double prime, that means really I want F prime, which is what feature? The slope. So if I go to 6 and I want to count the slope here, remember, you can only do that if it's linear. Okay, they can't ask you to hand calculate the slope on a graph unless it's a straight line. So let's pick 2 pretty points. Let's say I pick 6 and then this one down here, we're going to just count the rise over run. So from here to here, how many do I have to go down? I'm going to just do this little halfsy box. So I'd have to go down 4 and then over how many? Down 4 over 2. So my slope would be rise over run would be -4 over 2, which is -2. Okay, you're done with part A. Let's go on to part B. So the first thing they asked me to find is g of -2, then g prime of -2, then g double prime of -2. But I have to remember that I'm not looking at g, I'm looking at f. So if they ask me for regular g, my -2 needs to go into the x position, which is the top of the integral. So it'll be 2 on the bottom, -2 on the top. And then I know that in my head, if I'm integrating f, what am I really calculating? Starts with an A, the area. So shade on your graph between 2 and -2. So 2 and -2 would be this little piece right here. And then I notice it's basically the exact same triangle. So what will its area be? 8. Now, 8 is not the correct answer for this integral. So look at it and tell me, why is it not 8? It's backwards. Okay, my x was on, and really the x was on the top, but when I look at the order, when I plugged it in, this is backwards. So if you want to make a little note, okay, remember, if it's backwards, you just change the sign. Okay, so that's why we're putting a negative on our 8 area. Okay, g prime of -2 is going to be of -2. Which means that really I'm going to go to -2 on the graph, and then I'm going to pick the y value. What is the y value at -2? It is 0, because you're right there on the x-axis. Okay, then g prime of -2 is going to be the slope. And remember, it has to be linear or they can't ask you to calculate the exact slope. So -2 is here. I'm just going to pick a second pretty point and then count the rise over run. So how many would I have to go up? 4 and then over 2, which means that my rise over run is 4 over 2, which is 2. Okay, so far so good? Okay. Next thing that we're going to answer questions about is mins and maxes for G. Now, if G has a min, I want you to think about G prime would have to change how for it to be a minimum. Would it be plus to minus or minus to plus? For a minimum. Minus to plus. And then for a maximum, it would have to be plus to minus. Okay, so I know it's been a minute since we've done that. Okay, but a max is plus to minus, a min is minus to plus, and then there's also an option where you could have a neither. And remember, that would mean that your graph equals 0, but it doesn't actually pass through. So first thing I want to do is find our critical numbers. Okay, remember that critical numbers are where g prime of x is equal to 0. Okay, so if I had g and I wanted the critical numbers, I'd take the derivative and get g prime, then set it equal to 0. What feature is g prime on this graph? Y value. Where are the y values 0 on this graph? Okay, good. So -2, 2, 6, and 10. Very good. So those 4 blue dots, I want you to put those numbers in your answer for part C. So your critical numbers are going to be at x equals -2, 2, 6, and 10. And the reason why is because those are the places where your g prime equals 0, which we know means that your y value is equal to 0 on the graph that we're looking at. Okay, now let's go back up to our little blue dots and let's label which one is which. Remember, a plus to minus is a max, minus to plus is a min, and then a neither would be that it doesn't actually pass through. So let's start with -2. Is that a min, a max, or a neither? Min is correct because it goes from negatives to positives. That's a min. What about 2? Neither, because it goes from what? Plus to plus. That doesn't count, so that's a neither. Next one we're looking at is 6. Is that a max, a min, or a neither? Plus to minus, that's a max. And then what about 10? That would be a neither, because it changes how? From negative to negative, and that doesn't count as a sign change. So let's come down here and let's write that. So we're going to put that x equals negative 2 is a min because g prime of x changes minus to plus. Okay, that's really supposed to be pointing to the negative 2. Now let's do 6 next. Okay, for x equals 6, what did we say that one was? A max. Because g prime of x changes plus to minus. Okay, then the other 2 numbers that are left, the 2 and the 10, we said those are both neithers because g prime did not change sign. So because I ran out of room, I'm just going to put them here. Are neither because g prime of x didn't change sign. Okay, but then remember, every time we say g prime, we're really talking about f, which is the y values on the graph that we're looking at. Okay, now let's review because we haven't done this in a while. A relative min or max just has to have a sign change. An absolute min or max has to be the biggest. Remember, you can have multiple relative maxes or mins, but you can only have one absolute max and one absolute min. So the way that you tell if you have an absolute min or max is using a candidates chart. Okay, or a candidates table. And so let me remind you how to do that because I know it's been a while. Okay, for a candidates table, you're going to make yourself a little chart. And the only things that go in the chart are going to be the endpoints and the critical numbers. So if I'm going from -4 to 12, my endpoints are -4 and 12. And then I want to include all of my critical numbers, unless if I know it's a neither, then I don't have to put it in the chart. So for example, the 2 and the 10, they are critical numbers, but because I know they're not a max or a min, I know they're not going to win. So I'm only going to really include the -2 and the 6. Okay, you could include 2 and 10, but they're not going to win, and it's kind of a waste of time on a time test. Okay, then after you pick the endpoints and the critical numbers, you're plugging back into the original function, which is g of x, which has the integral in it. Okay, so don't forget that when you do a candidates table, you're plugging into the original, which is where my integral is. So if I wanted to do, let's say, -4, that would be g of -4 equals the integral from 2 to -4 f of t dt. G of -2 is going to be the integral from 2 to -2 f of t dt. Now, before I keep going, I'm going to have to find this one. Why do I not have to find this? Look back up at part B. Didn't we already do this? What was g of -2? Remember, it was -8. So you can go ahead and fill that one in. And then I also know g of 6. What was g of 6? +8. So I'm not going to waste time re-finding those. Okay, for these two right here, I already found those in part A and part B. So really, those are like kind of already done. Okay, and then we'll find G of 12. So that would be the integral from 2 to 12 of f of t dt. Okay, so let's start with the top one. Shade the area from 2 to -4. From 2 to -4. So on my graph, I'm going to start at 2, and I'm going to shade all the way till I get to -4. That would be all of this that I'm doing in orange. So -4 all the way till 2. Okay, those little orange pockets. Now, because this graph is a bunch of triangles, do you see that really these two triangles are just going to cancel each other out? Okay, because this triangle and this triangle, they're the same size. One of them's above, one of them's below. So pretend these two are gone. How much area is in that little halvesy triangle? Remember, they're both 8 if you look at the full thing. So how big is this part? 4. Now, where is the area? Is it above or below? 4 above. So is 4 the correct answer for the integral from 2 to -4? No, because why? It's backwards. So put a -4 here. Okay, because it's backwards. All right, let's do another one. Let's do now 12. So shade on your graph from 2 to 12. And then remember, we're kind of hoping that stuff is going to cross out. Okay, so I'm going to start at 2, and I'm going to shade all the way till 12. So that would be all this blue. Is anything going to cross out? Okay, the first 2 big 8 triangles are going to cross out, leaving me one little halvesy left over, which is how big? 4, and it's 4 where? Above or below? Below, so that means that it would be -4. Okay. Now, if it was also backwards, I would switch it to count as a +4. Okay, then looking at your chart, what is the biggest y value that you see? So the max is 8. It happens at 6. And then what's the absolute min? -8. It happens at -2. Okay. So we're going to just not work these two. There. So we'll say the absolute max is 8. It occurs at x equals 6. And the absolute min is -8, and it occurs at x equals -2. Okay, but remember that absolute mins and maxes, you have to be listing the y value, and then you can say where it happens, but you need to know exactly how high or low does it go. Make sense? Okay. Go ahead and turn to the next page. What do you think? We can't tell. All right. So take a look at your next graph. Okay, this is a graph of what function? F. What are they asking you to answer questions about? G. So up here at the top, put G of x equals. And then you can see here that the relationship is you're going to start the integral at -3. But x is going to be your upper boundary. Okay, before you go and plug in these numbers, I want you to write what G is, what G prime is, and what G double prime is, because you know you're about to have to plug numbers into it anyways. So G is the integral. What am I going to use this graph for if I need the integral of f? Area, very good. What about if I want G prime? What happens to the integral when I take the derivative on it? The derivative of the antiderivative crosses out, and you would just keep f of x, which is the y value. Okay, and then last one like that, G double prime of x would be f prime of x, which is the slope. All right, so go ahead and try A and B. So you're gonna find G of 0, G prime of 0, G double prime of 0. Give it a shot. So let's start with G of 0. And then you need to put the 0 where the x is, which is going to be at the top of that integral. No. And then stay negative 0, and then calculate your It's a trapezoid. Good. No, your brain has endless possibilities. All right, so let's get started. So put G of 0 equals. And then remember, whenever you're doing G, you're putting Yes, it's called T. Okay, so then from here, you're going to shade starting at negative. And you're going to shade until 0. And what's the very good. So you'll do 1/2 base plus base times height. Oh, Dyson, you're checking out. Okay. Okay, come on, let's get started. Okay, let's start with you. That's your X. Negative 3 goes on the bottom. And then I'm going to start it. I'm going to count back to negative 3. And then remember, I'm going to
what you like think about it is
So remember, 1/2 base plus base times height. And then remember the bases have to be parallel to each other. So then Rebecca, what would your first base be? Let's say it's this one. Base 2. And then what's the other one? So it'd be 1/2. 2 plus 1, those are your bases. And then remember, your height is how far between them? 3. I'm going to count it. Really, area is never negative. But I'm going to put a negative on it here because it is backwards. You know what I mean? So then 2 plus 1 would be 3. 3 times 3 is? And then you're going to cut it in half. So I'm going to just put 9 halves, but remember, we have to count it as a minus. Or 4.5. Negative 4.5 is fine. Okay, have we gotten the first one? Okay, so you do 1/2. Base 1, base 2. And then the height between them. Okay, so now we're going on to G prime of 0. So G prime of 0 equals. And if I take the derivative of the x, I will because I want to go from G to G prime, and now I want to take the derivative of this. And you know what happens? Plus that and do this. That's letting. And I'm going to be so we think about and then you didn't write your little top part, but I would do this first. G is the integral. Then G prime goes back to regular F. And then G double prime will be F prime. Yeah? So then now if you want F of 0, or G prime of 0, really you want F of 0, which would be what feature on it? Oh, you are using it. Okay. Yeah. So then once F of 0, go to 0, what is the y value? Okay, next you want the prime of 0, which means you want F prime. And F prime is what feature in the graph. Yeah. The slope, and are you allowed to take the slope at a little bit? Oh, I have never done so long. I know. Okay, just in case you want to check your answers for part A. Okay, you should have gotten okay, -9/2 for the first one when you found the trapezoid. 1 for the y value, and the slope should be DNE. Because remember, you cannot take the slope at a cusp or a corner. Okay, so at 0, you have a cusp. That means you're not allowed to count out the rise over run at that spot. Okay, so see if you can do B. Yeah. Oh, so it's backwards. So wait, no. No, you're right. It's positive. Yeah. Oh. Glass. It actually shouldn't be negative because this is already in the -3 is smaller. So they're already in the yes. It actually is a positive 90%. It is positive. Okay, are y'all done with A and B? Yes. How we doing? A and B are done? Yes. That's not one. Remember, if you want a min or max, it has to hit the x-axis. Remember? All right. Okay, let's keep going. Okay, most of y'all have A and B done. If you need the answers for B, I'll put them up here later. Okay, for part C, if I want critical numbers, remember that critical numbers happen when G prime of X is equal to 0. But what is G prime of X on the graph of F? The y values need to hit 0. So put big dots on the x-axis. How many places does it cross the x-axis? 1, 2, 3. And then let's talk about which one is which type. Okay, how does this one pass through the x-axis? Plus to minus or minus to plus? And minus to plus means that it's a what? Okay, min. Okay, what about this one? Min, max, or neither? Okay, neither. And then for the very last one, it goes plus to minus, which means that one would be max. Okay, so let's write that out. So at x equals, that's a -4. We have a relative min. Changes minus to plus. Okay, so write that down. At -4, you have a relative. Okay, girls, be ready? Okay, at -4, you have a relative minimum because G prime, which is really F, goes from negative to positive. Okay, then at x equals 1, you have a neither because G prime of x doesn't change sign. Okay, and then last one like that is at, this is 1, 2, 3. Because G prime changes plus to minus. Okay. All right. Then from there to do your absolute minimum. Remember, for absolute, you need a candidates chart. What numbers would go in the candidates chart? Okay, -5 and 4, those are my endpoints. And then any relative mins or maxes that are not neithers. So what other two numbers should I include? -4 and 3. And which of those did you already find the answer for? What was the value of G of X at -4 from part B? Wait, it should be in part B. Was it -9/2? For this one? This one? Yeah, it should be 1. No? Are you giving me this answer? Yeah, it's 1.
Oh.
Because we're doing this one here. You know what I mean?
Oh,
It's -1? Thank you. All right, so then we have 3 more left to find. Okay, so let's just find one of them, okay, rather than going through and finding all of them. So let's say that we want to find G of 4. Okay, obviously for a real candidates chart, you would need to find all of them. Okay, but just since we already did one like this, let's find G of 4. So it'd be the integral from -3 to 4, f of t dt, and then you're going to need to shade the area from -3 to 4 and calculate that answer. So let's look at our graph. We already know the trapezoid is 9/2. All right, let's try to focus in here, guys. So we have, this is 9/2 right here. Yeah, you're fine. And then I'm going to shade here to here. And then I'm going to keep shading here to here. Now, why am I not going to worry about those two triangles? Because I already know that they're going to cancel out. How will I find this blue area? We did it maybe in January. Rectangle minus half circle. Okay, so remember, this is a rectangle. What are the dimensions of it? It's a 2 by 1. What's the area of that then? 1 times 2 is 2. And then I'm going to minus the semicircle out of it. So it'll be area rectangle minus area of the semicircle. Okay. So we already said that our area of our rectangle is a 2. Because base times height is 2 times 1 is 2. And then how long is our radius for this semicircle? 1. So it'd be pi times 1 squared, which is 1 pi, and then cut in half. So it'd be pi halves. And then I would essentially be taking those two numbers and adding them up. So what is 9 halves is the same as 4.5 plus 2 more. So it'd be 4.5 plus 2 minus pi halves. Okay, 4.5 plus 2 minus pi halves. And then add these together. What would that be? 6.5 minus pi halves. Okay. All right. Next question says, find the values where points of inflection would occur. Okay, so when I'm talking about a point of inflection, is that a question? Okay, is that a question for G, G prime, or G double prime? If I want a point of inflection, what needs to change sign? Double prime. So points of inflection are where G double prime changes sign. But then what feature is G double prime on this graph? Slope. So go through your graph and I want you to put a big X everywhere that your slope changes sign. Okay, there should be 3 places. Okay, so if G double prime needs to change sign, that means the slope of this graph needs to change sign. Here's where your X's should go. Okay, you should have one here where it goes up to down. Then this goes down to down, so that doesn't count. This one counts, and then this one counts. So you should have 3 places that happens, here, here, and here. Now, the way it's going to ask you on your homework is it's going to say, where is the graph concave up or concave down? So question, if I was looking at this graph, okay, let's try to focus in. Okay, if your homework asks you where G is concave up, you would want this graph to have a positive slope. Where does that happen? So from -5 till -3 and 1 to 2. Okay, versus if I wanted it to be concave down, I would want -3 to 1 and 2 to 4. Yeah? Okay. There's one other thing that we have to cover that is sort of new. So turn the page and look at this last one right here. Okay. So first thing, okay, you have your equation written right here. I want you to do your little thing that we do up in the corner. So G of X is -3 to X on F of T. Then write what G prime would be and what G double prime would be. So what would G prime be and what would G double prime be? Okay, that should pretty much be your first step, is start with the integral they gave you and then find the derivative and the second derivative. What will G prime equal if G has an integral in it? Regular F of X. And then what will the derivative G double prime be? F prime of X. So on question B, I want you to think about that. It says, where would the graph of G be both increasing and concave down? So increasing, do I care about G, G prime, or G double prime? For increasing, I need G prime to be positive. But then remember, what is G prime here? F, which means if I want a positive F value, I need to be above the x-axis. I need to be in the positives. Okay, then it says, and I need to be concave down. Do I care about G, G prime, or G double prime? G double prime. And if I want concave down, I need G double prime to be what? Negative, which means what am I looking for on this graph? A negative slope. Very good. So identify there's two parts on your graph where you're above the x-axis and you have a negative slope. So when am I above and I have a negative slope? Okay, 0 to 2 is one of them. And -5 to -3, very good. So it'd be 0 to 2, union, -5 to -3. Okay. So now let's focus in on part E. So they're asking you to find capital F of 4 and capital F of -5. So I want you to write this that we had before. Okay, remember, this is your fundamental theorem of calculus. And then I want you to solve it for F of B. So if F of B has a minus F of A behind it, how can I get rid of the minus F of A? Just add it across to the other side. So we're going to call this version B of the formula. It's going to be capital F of B equals capital F of A plus the integral A to B of little n. Okay, so think about this and this are the same. The only difference is you're minusing the F of A here and you're pushing it across to the other side in version B. Now, here's why this one helps us out. If I want capital F at any number, yeah, that's okay. Okay, whatever capital F you're given, if you add that to the integral between them, you can find whatever time you want. So F of B is what you want. You're going to start with what you have and then integrate from what you have to what you want. Okay, so let me show you what I mean by that. I want capital F of 4. Okay, that's the first thing they asked me to find right here. So I would say, okay, my want is big F at 4. What is the big F that I have? They give it to you right here. It is given capital F of -3 is 2. And then I'm going to integrate between the time that I have capital F to when I want capital F. So I would integrate from -3 to 4 on F of X dx. And then from there, you can find your numbers. So F of -3 was given to me. What did they say it is? 2 plus, and then for this part, I'm going to have to find the area. So from -3 to 4, shade your graph, calculate your area, and that's what you would sub into that spot. So -3 to 4 would be from here until here. Now, as I'm shading that, what do I notice about those two triangles? Okay, this triangle and this triangle are going to eliminate each other. So that means really I only care about this half. So 1/2 base times height. My base is 3. What's my height? 4. 1, 2, 3, 4. So 3 times 4 is 12. Cut it in half is 6. So 2 plus 6, that gives me 8. Okay, so now set up your version B for F of -5. So capital F of -5 equals. Okay, capital F of -5 is what I want. What capital F do I already have? Capital F of -3. And then I'm going to integrate from -3 to -5. Okay, so this is what I want. This is what I already have. And then I'm integrating between them. Okay, what is F of -3? Same as last time. 2 plus. And then when I do this part, I'm gonna just calculate the area. So from -3 to 5, what shape are you highlighting? -3 to -5. Little triangle. And it's a 2 by 2. 2 times 2 is 4. Cut it in half, it's 2. Question, will it count as a positive 2? No, because it's what? Backwards means it's a -2. And then 2 plus -2 gives you 0. Okay. Good? Okay. Go ahead and log into your document.